Well, I'm not gonna lie. There's a couple YouTubers out there that, well, they like you to think they drive old cars because they fix them up all the time or they work on them all the time, but in the background you see them driving around in a new Ford or a new Chevy, because old cars, you know how they are. And, they may fix them all the time, but they don't want them as a daily driver. Well, this is our 1978 El Camino daily driver that we actually drive because right now we got nothing but old cars. So we need air conditioning because we're in Florida and we've been having trouble with the air conditioning. So let me show you some of the weird problems we've been having, which you might have too if you have one of these. And we're going to show you how to fix it. So if you have one of these Frigidaire A6 compressors, which, kind of looks like a long barrel like this, they're great heavy-duty compressors and they put out a lot of cold air, but they have a few sensitivities. And one of those is this front clutch on the front it can be heat sensitive. You see this big rubber section here? Well, that's what binds the central rotating shaft that keys into the compressor nose with the actual clutch disc that engages to be spun by the belt. And that can melt. And then you get this. So we've been having some heat problems, and rather than just throw parts at this thing like some people often do, it happens. And I understand you get frustrated and you just want it back on the road, so you throw another clutch on it or you throw another belt on it. We broke a couple belts due to heat and I didn't have time to fix it, so I basically put a new belt on it, and I haven't been running the AC. And I put a used clutch I had on it after this one melted on the road. So we know this is getting too hot for sure. I mean, it's getting really blazing hot. I also ran it for a bit with a thermometer, and you can see the temperature just tick up the longer it goes. I think our clutch is slipping because when we engage it, it takes a couple seconds to start spinning sometimes, and when I rev the engine, sometimes the clutch will disengage and stop spinning. So anytime that happens, that's just bad, because that's heat buildup, and anytime the clutch stops and starts, that's heat buildup. And especially if it stops in the middle of spinning when the compressor and the clutch are engaged, because it's trying to re-engage the whole time and it's just spinning and spinning. I don't know if you can see on this wheel, it's just the steel is blued. The clutch steel is blued from the heat. And this was from the brand new compressor that I put on not too long ago because the nose seal started to leak, which may have been from a heat buildup as well. All that can be related because there's rubber seals on the nose seal. So this compressor is relatively brand new and the clutch is brand new, etc., etc. So we know the and the other compressor and clutch was probably having the same problems from what I can see, because this is the clutch from that old compressor, and it was slipping and I had to deal with it. So there's an electromagnet in here, and these basically engage the electromagnet and suck the clutch discs together when you hit that AC button in the cabin. So I'm thinking that this electromagnet isn't quite strong enough to keep that engaged against the forces of the engine. Like when you rev the engine, it can cut loose and spin. So we're going to check this out because I've checked out a bunch of other things. The belt tension, the belt tension is great. And everything is aligned. The pulleys are aligned. The bearings are great because they're brand new. So there's really no other source of heat in there since these parts are all brand new and I know they're all okay. So the wiring on these, it goes, and as you can see, this is a 2-wire clutch. It doesn't just ground it. It goes through the clutch and grounds it to an external circuit somewhere over there. There's a thermal sensor and all that on these things. So we got to check the ground and we got to check the wiring because we're losing some voltage somewhere in there, I think. But let's check that out and find out what we got. So right now our battery voltage is at 11.89, taken directly from the battery. 11.9. Okay, note that later because Now let's check what it is at the AC clutch. So over here at the AC clutch, taken right from the plug, we got 11.21 volts. So, oh, it's dropping a little bit, 11.2-ish. So that's a drop of almost 3/4 of a volt. So you wouldn't think that's enough to do anything, but I think that might be part of our problem. Okay, so we are losing some voltage. Now, when this car came from the factory new, it had a thermal cutout back here in the back of the compressor, a thermal switch that would disengage if the back of the compressor head got too hot. Now, you can't find those switches anymore. There's two types of switches, and the one type I need I can't find. So I'm not using it. I have bypassed it and changed this system instead to use a pressure cutoff switch to save the compressor if it runs out of refrigerant. And it also has the temperature cutoff, so if it gets too cold and things start to freeze up, it will cut off. And that's what one of these here is, this one or that one, or both of them. I gotta look it up, I can't remember. But anyway, there's a lot of wiring involved in there. So rather than just supplying power when you hit that switch, it's actually, you know, running back through that whole thermal limiter circuit and all that stuff. So there's a good possibility that one of those parts is old, weak, or something, and it could be limiting the voltage and thus the amperage available to that clutch. Now we could put a relay system on here so that when you engage power to these two prongs, it actually engages a relay which sucks power right from the battery to the clutch. We can do that. I'm not against that because that's a better system. You'll see that in square body Chevys like ours over there. The headlight circuit runs through the switch on the dash, which has a fuse, thermal fuse, rather than a relay, and back to the lights again. And it's just a long circuit, and they make an add-on that just adds a relay that when you engage the light switch and everything, it engages a relay which cycles power right from the battery to the headlights. So there's just a short run of actual high amperage current. We could do that here. I'm not against it. This car is very original, but we want it to work too because it's a daily driver. It's not perfect, and we use it for work and stuff, so we want it to work. I want it fixed, and I want it fixed right, because I've been limping this thing along for a while now, waiting for time to fix it. We're going to check out the electrical system here and see if we can find the problem. And if we can't trace down the exact problem, we're going to simplify it and see if that makes it, you know, a little bit, gives us a little bit more current to the clutch. So on these 1978 models, I think 79s as well, and possibly some others, you'll see 3 wires. This is the air conditioning circuit. There's 3 wires. Well, 2 wires from the factory, because what happens here is this wire, the ground wire, goes to the back of the compressor back here with that switch I was talking about, and it's grounded until it opens if it overheats. And then this is the solenoid that kicks the idle up for when you have your AC on. And of course the other wire is power for the clutch. So we got ground and power, and we got power. Of course this grounds on the carburetor frame. So I had rerun that wire, the black one, over here. So right now the ground circuit goes through this low pressure cutoff rather than the thermal cutoff that would have been on the back of the compressor. So that ground wire comes across the engine compartment over here through this. I did that for ease of changes when I did this, because rather than cut the power wire, the ground wire was already cut because I was pulling the thermal switch out. So it was easier just to run that rather than cut and resplice 2 wires. So right now we're checking the negative line that goes around the engine compartment through the sensor and back to ground from the compressor clutch. So we're basically checking the whole negative side of the circuit. So we're getting about 0.9 ohms. That's not terrible. for the amount of wiring, and it has to go through the pressure switch and I think the thermal switch that might control the positive side. I don't know. It's a little bit, okay, 1.1, you know, my meter is not tremendously, you know, it's digital, so it'll flit around a little bit. So 1.1 ohms, still within what I would expect. Okay, so now I have it hooked to the positive side of the clutch circuit here. And I'm just testing the wire that loops around the back of the engine right now that goes to the thermal switch, which you can trace down from this line here, which is right down in here, if you can see it. That's the thermal switch. So see if we can get a good connection on there with my alligator clip. Okay, so we're getting 1.7 ohms, 1.6 ohms on that wire. Okay, 1.5. That's in line with what we're seeing on the other side, roughly. Not terrible. Not going to prevent a lot of amperage from passing through there. So now I've got my meter leads on the two contacts on the thermal switch. And, well, we're jumping around a lot. Could have dirty contacts. Could be my meter. See if we can seat these alligator clips a little better here. There's a lot of connections in this AC system, so if you get corroded connections, it can cause this problem as well, because it creates heat and loss of amperage. So see how it's jumping around a lot there. Now the reason this has a thermal switch with a thermocouple line that goes to the evaporator core is because these A6 compressors are made to run all the time. They're not made to cycle on, off according to pressures. They're made to run all the time unless they get the compressor overheats, which is what the switch on the compressor is for, or the evaporator starts to freeze up. And that's what that thermal switch is for. So that's why they have to use a thermal switch rather than the modern high pressure, low pressure system where it just cycles the compressor on, off if the pressure gets too high or too low. So we've already bypassed one of those with a low pressure switch. Now we could add a high pressure switch. In this case, it was easy to add a low pressure switch because the receiver dryer already has a port, because it's, you know, standard GM receiver dryer of that era. The high pressure side, we would have to add a port somewhere for the pressure switch, and there's not a direct port in the back of the compressor so much as it is just a circular hole, and the old switch is held in with a snap ring. What are we at here? It's jumping all over. It's going anywhere from 50 ohms to 38 ohms. That could be part of our problem. Now I could bypass that and just run it, and it would run. The problem is, if your evaporator does freeze up, then your compressor is trying to push refrigerant through that frozen core, and it can't, and the high pressure will just keep building and building and building and building, and there's nothing to shut it off because there's no thermal limiter here, because the heat builds up as your pressure builds up. So there's no thermal limiter to cut it off, and there's no thermal limiter on the evaporator core to shut it off. So you could risk blowing up your compressor and potentially other things. So I'd rather not do that if at all possible. Yeah, see, now we're at 56, 57 ohms. I can try cleaning up those connections and see if we can do that again. 50, now we're up to 63. That's not a tremendously high reading necessarily, but every little bit of that will build up heat. Let's keep checking and check out the other parts of the system and check it all the way back to the actual source of positive power for this circuit. So I've reduced some wiring runs by grounding the compressor right there and running the low pressure switch through the positive side of the circuit instead of the negative. So now all the switching happens on the positive side of the circuit. We're down to 1 ohm, 1.1, it's clicking around. on the positive side from the compressor plug to the plug on the thermal switch. Now that does not include the thermal switch, so that's acceptable. That does include the low pressure switch. It goes from the compressor through the low pressure switch and then to the thermal switch. So we have to figure out what we're going to do with the high resistance of the thermal switch. Now obviously there's probably some natural resistance built in, but I'm going to clean up the contacts and things, and that probably won't change anything, but it's worth a shot. Total resistance of the ground circuit over to the fender terminal on the battery, which goes right to the battery connection, is 1.1 ohms. So we've kind of just a hair lowered those things, but the one remaining problem is the thermal switch and the wiring. We don't know about the wiring that runs into the cabin through the actual switch and back out. Might have to replace the power circuit with a relay. So I've run a relay directly to the compressor clutch. As you can see, we're getting a full 12 volts instead of the barely 11 we were getting before. So basically all I did was run a relay and I spliced it into the power circuit so that the switching circuit just activates the relay, which then switches power directly to the battery through a fuse here, 15 amp fuse, and right over to the compressor clutch where we get a full 12 volts. So hopefully that should improve, maybe fix, our compressor clutch engagement problem and overheating problem. Hopefully getting that full power now to the clutch will keep it from slipping, because it'll have more power pulling the two clutch plates together. Don't do this. Who needs a lathe? Or the proper way to, you know, resurface and burnish things. Right now there's a bunch of old AC guys just totally freaking out. This is going to be replaced. I'm just trying to get it so it doesn't slip during engagement right now. We don't need proper procedure. Okay, maybe we do. Nope, we don't. I went over a speed bump out there, about maybe jump and lose my hand in the fan. This is OSHA approved. Jump with me and you'll see the world of OSHA violations. Yeah, I know I didn't invent that, but it seemed really appropriate. So, sir, how did you lose that hand? Well, you see, I was burnishing my clutch. Yeah, sure you were. I'll bet you were burnishing your clutch. Better than I was. That should be good enough for 1 or 2 engagements, right? Who needs an engagement? Just get married. Obviously, we can't really do the same thing with this one that we did with the other one. Vent holes are cleaned out there. Alright, let's put this back on and see what happens. Probably nothing. Don't use that method at home, fellas. Well, I mean, don't do that at all. Replace your clutch. I think we're good now. It's good enough for government work. So let's test this out. Start up the car here. Alright, it's running. So now, let's check for slippage when we engage this. Actually, she's not slipping at all. Alright, let's check for slippage when we rev the throttle. Get your finger caught in it. There's a little tiny bit of slippage at first, but that's because this is a worn clutch that I put on, and I knew it wasn't perfect. It needs reburnished and everything really to be perfect, but I put it on for testing purposes, and she's not slipping like she was before. But once it's engaged, it stays engaged. My problem was really before, it would engage, that's fine, but then it would slip during operation. Like you'd goose the throttle and it would stop and then engage again, maybe, if you're lucky. Otherwise it would sit there and kind of, you know, heat itself up because we were pulled close together but not close enough to actually engage, so that creates excess heat. Let me get my thermometer. Let's check temperature. So I'm checking the temperature of the rubber disc here. So right now it's about 112, 113. The pulley is about 118. Back of the compressor is 124. So that's good. If the pulley starts getting hotter than the back of the compressor, that means that the pulley is obviously generating more heat, because the compressor should be the most heat generating thing in here. So if the pulley's generating more heat, that means you got a problem in there. So now what I'm going to do is check for heat buildup over time, and that'll tell me if it's slipping, because if it's building up more heat than it can get rid of, then obviously it is going to fry the clutch rubber again. We don't want that. So she's been running for a couple minutes. We are still at, come on now, cooperate, still at about 120 on the rubber. That's good. It's not heating up, or if it is, it's not heating up very fast. 147 on the back, and oh, come on now, I gotta replace the batteries in here. 144 in the front of the compressor, so that's good. She's about down to 60 now. That's good. That's excellent. It's a hot day out, so you know, it's working against the El Camino greenhouse effect with all that glass and very little roof in the middle, you know, with the sun just shooting down in there. So she's working pretty good. Still no slippage even when hot. She's not slipping at all. I should have taken video to show you before how it was slipping, but I mean, you can just tell that 1 volt, which means you're losing a lot of amperage there. If you're losing a volt, you're losing a significant amount of amps. That makes a big difference on these things. So if you're having compressor clutch issues on your A6 compressor, especially on these old GM vehicles where they run the power circuit all the way through the switches and everything in the vehicle and then back to the compressor, you might need to install a relay to just, you know, get power direct from the battery when that's on. She's running good. I think that'll do the job for me. And by the way, as a note on these, you can also make your headlights a little brighter by doing the same thing. My significant other has complained that driving this thing at night is really hard because the headlights are a little weak. Well, that's because they run the headlights, same thing, they run the power circuit into the cabin through the switch and then back to the headlights, and you can install a relay to do the same thing if you want. So that'll do it for the air conditioning system on our El Camino for today. Hopefully that was useful to someone. Just a quick little thing to check if you're having clutch issues, if you're melting the rubber, or if you had a lot of clutch slippage or belt breakage. You know, belt breakage can just be the belt deteriorating from lots of heat buildup, and then it finally snaps like a rubber band and, you know, shoots it all over the engine compartment. You know, I've got a lot of experience with that. But hopefully I won't be going through belts and clutches anymore, and we'll have some nice dependable cooling on our daily driver El Camino here. If you made it this far in the video, we appreciate you watching. We appreciate all of your input, comments, questions. We really appreciate subscriptions, helps the channel grow. Any likes, comments, questions you have, leave them down there below. And as always, thanks for watching.